All right, in this video, we're going to be introducing kind of the basic geometry when we're thinking about water pipes and water reservoirs. So we're going to start with the circle. So we find a lot of different shapes in the water industry, but really the most common one we're going to use in this class is going to be with circles. So whether we think of this as a pipe, right? Imagine it's the inside of a pipe, or we can think of this as the top and bottom of a reservoir, right? Sitting on top of a hill. Either way, though, in order to calculate the amount of water in here, or the amount of water flowing through a pipe, we need to know the dimensions of this circle, right? That whether it's attached to a pipe or reservoir doesn't really matter. We're going to do it all the same way. So remember that circles are a little bit more unique from, say, rectangles, for example, and how we calculate those. So it's really important to remember that with a circle, we've got our circumference, right, which is the length of the circle as we wrap around it, right? If we remember a rectangle, the perimeter is just going to be this side plus this side plus this side plus this side, right, as if we're walking along. Well, the formula for the circumference of a circle is not that easy, right? We can't just start and stop based on those measurements. So we need to know the diameter of our circle, right, which is a line that goes straight across. We can also do it with the radius, right, which is half the diameter. We're going to use diameter because that's what we use here in water math all the time. Now, for the circumference, we're going to be using the formula pi times diameter. Now, pi, depending on what kind of calculator you're coming from, you can substitute with 3.14. It's going to be close enough relative to the magnitude of what we're doing in this class. If you got the pi button, you might as well use that though. So this is the unique formula we use for the circumference of a circle, right? The outside of. Now, there are going to be times in this class where we do use that. I'm going to focus right now more though on the area, right? So the area of this circle, this is what we're going to use when we're calculating flow through a pipe or volume in a tank. The area is this part right here that we're talking about. Now, in our traditional math, we think of area as being pi times the radius squared, pi r squared. In water math, though, we use a shortcut, if you will, a simplification of this. We're going to use the formula 0.785 times the diameter squared. Now, this 0.785 comes from if I have a perfect circle like this and I draw a perfect square around that circle. The area of this square here is just going to be whatever this length is times this length. Well, this length of this rectangle or the square here is actually the same as the diameter of my circle, right? So if I do length times length, this tells me the whole area of this, which is equal to the diameter of this circle. However, when we're looking for the area of just this circle, we don't want these little corners here, right? So what we want to do is we're going to basically, quote unquote, subtract those out. So the circle here is approximately 78.5% the area of this square here. So that's where this 0.785 comes from. The diameter squared, that alone would give us this square here. We're going to times it by 78.5%, which is the area inside of that circle. Right? So this is the formula we're going to use when we're looking at area of a pipe, area of a reservoir that's circular, cylinder in shape. So let's take a look at an example here real quick. We've got a circle. We've got a diameter here in the middle that's going to be equal to 24 inches, right? Let's say we're talking about a water pipe. Now, if we're trying to calculate the area, we're going to use our 0.785 formula times my diameter squared. Now, when we calculate the area of a pipe, it's important that we want the area in terms of square feet. And you're going to see this when we start calculating flow, reservoirs, and all that. We always want to be in terms of feet. So even though I'm given my diameter in inches, I want to make sure I plug it into this formula in terms of feet. So how do I go from inches to feet? This is an easy one because it's just two. But how do we do it for any measurement? We're going to start with what we've got, the 24 inches. We're going to put it over 1 for simplification here. And we're going to figure out what is that conversion factor that's going to get rid of those inches. Right? So we need to know we always put it on the opposite side to get rid of it. Inches. We're trying to bring in feet. Well, how many inches are in a foot? There's going to be 12 inches for every 1 foot. Right? This is going to cancel out my inches. So essentially, what am I doing? I'm doing 24 divided by 12. Right? And the reason I'm doing that is in order to cancel out the inches and bring in feet. So in this example here, my diameter ends up being 2 feet. So 0.785 times 2 times 2, right? Because it is my diameter squared. Notice the units on that. When I do feet times feet, I end up with square feet, which is what we want for an area. So 0.785 times 2 gives me 3.14. And that is square feet. So that's going to be my area. Now I can take this and I can do a lot of things with that. So in the next steps here, in the next couple classes, then we're really going to dive into flow and volume.